In our 3 solvents lab, we are going to be looking at 3 individual solvents and how they affect several different solutes. So our 3 solvents that we're going to be dealing with, the liquids that do the dissolving, are of course water, ethanol, and hexane. And one of the things I really want to think about when I look at these molecules is this solvent a polar solvent made of polar molecules, or is it a non-polar solvent? So when I look at water and ethanol and hexane, the first thing I want to look at to decide if it is polar or non-polar is to decide if it has any polar bonds. And the way to remember if something has a polar bond or not is to look for 2 different elements that are not carbon and hydrogen. Any other bond is going to be considered at least slightly polar in terms of the AP exam. So OH, absolutely a polar bond, a very polar bond. So water has 2 polar bonds in it, one between each of the oxygen and the hydrogen. Okay. Ethanol has some non-polar bonds. C and H is considered a non-polar bond, but it does have 2 polar bonds in it between the carbon and the oxygen in the hydrogen. Hexane, on the other hand, has no polar bonds at all. All of the bonds are either CC bonds, which are bonds between elements that are the same, so they're nonpolar, or CH bonds, and CH bonds are considered to be nonpolar because the electronegativity of carbon and hydrogen is so very similar. Now, just because something has a polar bond does not necessarily mean it is a polar molecule. Remember, what we want to look for is the symmetry, or the electrons, how it lays in the molecular shape. Water is a bent molecule. It is asymmetrical because not drawn in this space-filling model are 2 lone pairs that live on the oxygen atom. So oxygen's higher electronegativity and the 2 lone pairs that belong solely to that oxygen means that there's much more electron density on the oxygen side than on the hydrogen side. This is a lopsided molecule. It's partially negative on the top where the oxygen is and partially positive on the bottom where the hydrogens are. And you can measure this dipole moment in a unit called a debye. Water has a quite high dipole moment of 1.77. Ethanol, since it is in a lot of ways very similar to water, you can see this shape here made with the oxygen is really pretty similar to water. It is also bent around that O, is also a polar molecule, but you can kind of see this end down here with all the carbons and hydrogens. That's a lot more electrons than just a hydrogen by itself. So this is a slightly less polar molecule. And in fact, we see that its dipole moment is 1.66 debye, so smaller than water, but still reasonably polar. Hexane, on the other hand, has no polar bonds, so it doesn't matter whether it's symmetrical or not. It is a nonpolar molecule because it has no polar bonds. And it has no dipole moment because it is completely non-polar. So summing things up, we have an extremely polar water molecule, so we have a very polar solvent. We have a somewhat polar solvent, ethanol. And we have a completely non-polar solvent, hexane. And we're going to see how the polarity of our solvent affects what can and cannot dissolve in a substance. All right, before you start testing your substances, you want to work and check with your group. So before watching the rest of this video, work and check with a discussion partner. Write the formula of any compounds that are not given on the page, so there are several. Decide if that compound is ionic or covalent. If that compound is covalent, you need to decide if it is polar or non-polar. Polarity is something which applies to covalently bonded substances. It is not something that has anything to do with ionic compounds. Polarity is a partial positive and negative charge. Ionic compounds are completely positively and negatively charged. So if it is ionic, you can just write Na in the polar versus nonpolar column there. And the last thing you want to do is predict the solubility of these different substances. And it is, remember, it's a hypothesis. It's okay if it's wrong. If your prediction is wrong, then you learned something. So it's fine. Don't go back and change it and make yourself look like an amazing psychic-powered individual. Make a prediction and stick with it. That's not something I'm going to grade for were they right or were they wrong. It's a thing that you predict before you do the test.
Let's do our solubility tests in water. So all of these test tubes are full of about the same amount of water. And we're going to take a very small amount of each of our solutes and try dissolving it in the water. It has to be a very small amount because we're not using a large amount of water, our solvent, so we don't want to overwhelm the capacity of our solvent to dissolve the solute and think that it's not very soluble. So we're going to start with iodine solid, and we're just going to put a couple little iodine balls in there, and then we're going to agitate this. We're going to make it go back and forth and back and forth. Okay, so iodine, well, I don't really see anything happening to that, so I think we can say that iodine is clearly not very soluble in water, if at all. So our next substance we're going to test is ammonium chloride. And that is, of course, an ionic compound, being as how it has ammonium, a polyatomic ion, right in it. So we're going to get just a tiny amount of ammonium chloride on the tip of our scoop, just a little tiny bit. It's a white solid, so we're going to drop it in there. And then we'll do the same thing we did before. We'll take it and we'll agitate. We'll stir it back and forth a little bit. And, oh, you know, I think that is soluble. I don't see any solid left in the bottom of this at all. It seems to have completely dissolved, so you don't see any solid down there at all. So the ammonium chloride appears to be quite soluble in water. The ammonium chloride is soluble. So now the next thing is going to be our naphthalene, which is very smelly. A lovely covalent compound, all C's and H's. So we're just going to take a little chunk of it, drop it in there. This is my third substance. Ugh, so smelly. And again, we'll agitate it to see if we can get it to dissolve. And we can see that the naphthalene here is floating on the surface of the water. But you can still see that chunk that I put in there is right there on the side. You can kind of see it floating around on the top of the water. Let's see if I can kind of change the angle, see it moving. So naphthalene appears to be insoluble. It does not dissolve in water. We can see those chunks there are just not really going anywhere at all. So naphthalene is insoluble. So right now we have two insoluble things and only one that is soluble. The next one we're going to try in tube number 4 here is copper 2 sulfate. And I think if you've actually been around the classroom paying attention, you might kind of already know the answer to this one because I was doing a lot of work with copper 2 sulfate earlier this year. So I'm going to put that in there. It's bright blue. So we can kind of see that blue solid down there. And now we'll agitate it a little bit. It's kind of a big chunk, so that might make it a little slow to dissolve. So we'll agitate this for a minute. And I do see that blue solid is still down there, but I feel like it's a smaller chunk than what I put in. So let's give that a minute and see if it will completely dissolve or not. Another thing I might want to do with some of these colorful substances, I might want to try putting something behind it and seeing if I see that the entire solution is changing color at all. So that's a thing I might want to look at too. Okay, so alright, our next one we're going to test is some copper 2 sulfate, which is a blue solid. So I'm going to put that blue solid in there, and we're going to agitate for a minute and see what happens to our blue solid. Remember, this is what it looks like in the bigger chunks. Oh, okay, so let's see what I get. I put in one bigger chunk and some smaller pieces. And I do see that this bigger chunk probably is still in there. Kind of see that blue color moving around a little bit at the bottom, but all of the little pieces I put in, they are super gone. So this does appear to be soluble in water. Copper 2 sulfate looks like it is soluble. I don't see any solid in there anymore. So no more solid means that solid must have dissolved. So copper 2 sulfate is soluble in water. So we'll get our container of glucose and tap, tap, tap it in there. You can see some of those solid bits floating down. And just like we've done in the other ones, we want to go ahead and agitate this. So we'll stir it back and forth and agitate. And this time you can kind of see that solid flying around down in there. So I do think some of this dissolves, but it might not be as soluble as some of the other things that we've seen. Oh, really? That looks like it's pretty much dissolved. So I think we can say that glucose is soluble in water. Seems like it's more soluble than table sugar, which is sucrose. Sucrose is a much larger molecule, so that might have something to do with it. I mean, that makes sense. We certainly know that we can have sweet drinks. And then our last thing is our sodium chloride. And I think anybody who's familiar with the concept of the ocean ought to not be too surprised with the outcome here. So I'll agitate this, and I do see a little solid. And then this time when I agitate, I see less. And now all I really see is just some bubbles coming up. I don't really see any solid at all. So the sodium chloride does appear to be soluble. So in water, what we've been testing here, solubility in water, we can see that our iodine, let's see if we can kind of see those down there at the bottom. The iodine is just hanging out at the bottom, not really doing anything very interesting at all. Ammonium chloride was very soluble. It completely disappeared. we can still see the naphthalene floating on the surface here of our water, so it's not soluble in water. We still don't see any solid in our copper 2 sulfate solution, so that is soluble. The glucose solution appears to also be fairly soluble. And the last one was our sodium chloride. Again, I don't see anything there. Sodium chloride appears to be soluble. So now we're going to run these same samples through ethanol to decide whether we think that it is soluble, whether we find that these things are soluble in ethanol. Ethanol on one end is kind of very similar to water, but the other side of ethanol is all C's and H's. So we're going to start with iodine. Oh wow, and I actually immediately see a difference in the iodine solution. Wow, you can really see that dark brown color that forms. So that clearly tells us that the iodine is soluble. In fact, you can even see that dark color forming at the bottom there. The solution getting darker as the iodine does dissolve. Okay, so clearly iodine is soluble in ethanol. So that's our first result. Iodine does dissolve in ethanol. Okay, so the next thing we're going to do is ammonium chloride. So again, we just want to use small amounts because we don't want to overwhelm the ability of our solvent to dissolve at all. So I'll put just a little bit on the tip of a scoop in there. You see the solid falling down through the ethanol, but we want to give it a fair shot. So we're going to agitate this. And I still see the solid down at the bottom, especially as I agitate. We can really see that solid swirling around. So I really don't see this disappearing. And I really still see that solid swirling in the bottom. So I think we can say that ammonium chloride is not particularly soluble in ethanol. You can kind of really see that solid there on the bottom of the test tube. If I kind of angle it a little bit, you might be able to see it there. So ammonium chloride does not appear to be soluble. So the next thing we're going to try is our naphthalene, and we're going to remember that we might have to look at the top of the solution for this because last time it floated in water. So I'll put in our naphthalene, and again I saw that really just kind of fall through the solution. But again, we do want to try, give it a fair shake and make sure that we agitate a few times. And I see this time it didn't float, but I do see those chunks of solid still down there at the bottom. They're just kind of floating around. You can still see them moving around. So we can come back and check on it, make sure it isn't just slowly dissolving. But I really don't think that this is particularly soluble. So there's our iodine, ammonium chloride, and naphthalene. So now we're going to try in our fourth tube, which is this one here. We're going to try a little bit of copper 2 sulfate. That was pretty in blue, so I'm going to take some pretty blue crystals. Drop them down in there, and I see them sitting at the bottom. So you can kind of see, if I tilt that, you can maybe see that blue reflecting off the table there. So let's try and agitate that though and be fair. Can see that blue down there though. See that chunk of blue? So it doesn't look like copper 2 sulfate is soluble in ethanol. So we have glucose and we have sodium chloride left to test. So scooch this down so we look at our last two tubes here. So we'll get just a little bit of glucose on the tip of our scoop and drop that down in there. Again, I do see that solid moving around, but I don't want to make a decision until I actually agitate it and try it, because we want to be fair. So I kind of see that cloudiness when I start to agitate and swirl. So I can still see that cloudiness spinning around. I really don't know that I can say that the ethanol is very soluble. I know from actual life experience in the kitchen that it is at least a little bit soluble, but certainly doesn't appear to be very much. And our last one is our good buddy sodium chloride. So we'll test that out. Well, if I can get it to stay on my scoop. So we'll put a little in there and see where we get. Put the lid back on the sodium chloride so it doesn't get spilled. And we'll agitate. And yeah, you can see that sitting just at the bottom there. So the sodium chloride does not appear to dissolve in ethanol. See it down there? So if we have our ethanol results, we can say that, remember, iodine was extremely soluble in ethanol. We can see that dark color that formed. The ammonium chloride was a no. The naphthalene, we said we'd check one more time just to be sure. But yeah, you can still see that solid sitting down there at the bottom, so that's a no. Copper 2 sulfate, we saw that blue sitting still at the bottom. Glucose, not much, if at all. And sodium chloride is a no. So we had one yes and a bunch of no's on ethanol. All right, we're going to test our same 6 substances now in hexane, which is a non-polar solvent, all C's and H's. So we'll just gather a couple little bits of iodine and drop that in. That's interesting. When I drop in the iodine, it looks really kind of purple. In fact, if I look at that closely, wow, that's interesting. Look at that purple moving around in there. So I can see here this whole solution is becoming purple. This means that iodine must be soluble in the hexane, because the solution is really going a different color. What I find interesting here is, remember, iodine was soluble in, I can even see it swirling up there from the bottom. Iodine was soluble in ethanol, but when we dissolved it in ethanol, it turned orangey brown. It didn't turn purple like this. So that's an interesting thing, that this appears to be soluble in both of these solvents, but I got a solution that was a different color, which is kind of fascinating. So yes, iodine dissolves in hexane. So we're going to go through the rest of our samples one at a time. So our next thing is ammonium chloride. Get a little bit on the end of our scoop and drop it in there. Again, we saw that solid just fall right through, but we never want to make a decision until we actually agitate it a little and see what we find. Again, I can see that solid just swirling around. You can see that solid down there at the bottom. It's really not seeming to go much of anywhere. So I think we can say ammonium chloride is not soluble in hexane. So the one thing we haven't been able to dissolve in any of our solvents yet is the naphthalene. So I'm curious to see if maybe this will dissolve in hexane. Maybe stinky things dissolve in stinky things. I saw the solid fall through, but let's agitate and make a decision here. And maybe one more little agitate. Let's see if we still see any solid in the bottom. So, yeah, I really don't know that I do. Wow, okay, so maybe this is the thing that finally dissolves naphthalene. I don't really see any solid in the bottom of it anymore. See, no matter if I tilt it at any different angle, I'm not seeing a solid. So, all right, we have finally found the thing that will dissolve our naphthalene. Naphthalene is soluble in hexane. All right, so we have a yes, a no, and a yes. So now we're going to try our copper 2 sulfate. We got to get some little bits of this to try it out. To do a little digging around in my container. The chunks are kind of big, but there we can get some little pieces. So we're going to take our little pieces and we're going to go straight into this fourth one. I don't feel like I'm going to have a lot of luck here, but again, we don't want to make decisions until we really agitate. But I can see that blue is sitting down there at the bottom. Even though I'm agitating it several times, we can still see the blue down there. Try really one more good time. Nope. Doesn't look like copper sulfate dissolves in hexane. It appears to be insoluble. All right, so we have glucose and sodium chloride, 2 more to go. See that glucose just kind of sinking down through. It's very, very fine powder. Much finer than table sugar, which is sucrose. So I can see that kind of almost looks like a snow globe where it's just swirling around. Let's see again if I can kind of tilt this up, if maybe we can see if there's any solid at the bottom. And yeah, when I put it down on the table, you can really see that solid chunk just kind of sitting down there on the bottom. I can agitate it and swirl it around, but then it just seems like it's settling right down back as a chunk on the bottom. So I think we are going to say, yep, look at that. No dice on glucose. That is insoluble in hexane. And our last thing is some good old sodium chloride. So we'll get a little on our scoop. And we'll see what we get here. Okay, I saw some of that just kind of hit and stick. But again, of course, we don't want to make decisions until we actually do some agitating. Yeah, this almost doesn't even act like it wants to even agitate in here. Look at all that. It's just sitting right there at the bottom. We can see that white at the bottom of the tube. Even if I agitate, it's kind of interesting in that it almost just acts like it doesn't even want to stir up with the water, or with the hexane. Sorry, this is not water for sure. Water does not smell like that. So you can see that solid just sitting there on the bottom. So I think we can say that sodium chloride is insoluble soluble in hexane. So we have soluble, interesting, in pink. We have insoluble, we can see that sitting down at the bottom. The naphthalene is soluble. I don't see any solid in here at all anymore. Not if doesn't matter what angle I try and put it at. Okay. My copper 2 sulfate, you can see that chunk down there. It is insoluble in hexane. Glucose appears to be basically insoluble in hexane. You can see that solid still sitting at the bottom. And sodium chloride definitely still sitting there at the bottom. Okay, so here's a summary, and we can look at our data table. So I'm not going to tell you whether these are ion or covalent. That is your job. Hopefully you have already made your prediction here. So we see that iodine is insoluble in water, but does dissolve in both ethanol and hexane. Interesting, it is kind of brown-orange in ethanol and bright pinky purple in hexane. Ammonium chloride did dissolve in water, but did not dissolve in ethanol or hexane. Naphthalene did not dissolve in water, did not dissolve in ethanol, but did dissolve in hexane. Copper 2 sulfate did dissolve in water, but it did not dissolve in ethanol or in hexane. The glucose dissolved in water, but is insoluble in ethanol and hexane. And the sodium chloride, anyone who's familiar with the ocean should be able to tell you that is soluble in water, but it was not soluble in ethanol, and it was not soluble in hexane. So now we can start making our lists down here. List the things that were soluble in water, the things that were most soluble in ethanol, the things that dissolved in hexane. So we have a few questions to answer here, and we can get on with that now.